everyone, welcome to my channel. Let's learn the algorithm together. Today let's take a look at the 3, 4, 7 top k frequent elements. So what is this problem talking about? We'll be given an integer array numbers and an integer k, then return the k most frequent elements. You may return the answer in any orders. Like for example, we have the number something like 1, 1, 1, 2, 2, 3, and k equals to 2. It means that we need to return the top 1 and top 2 frequent numbers. Like in these numbers, we can calculate like that, like 1 equals to 3 times, so this is the numbers, and this is the count. And 2, it has occurs twice, and 3 it occurs like 1 time. So the top 2 will definitely be the numbers 1 and 2. So we return this. And if the numbers is 1 and k equals 1, and just return 1. So probably this is what we're gonna to solve. And now I also have a questions like if the numbers they occurs at the same. For example, like you have 2 here, and then shall we return? But we need to return like the k equals to 1, and now there are 3 times for 2, so which one should we return? Is there any hint here? K is in the range of 1 to anything. Well, it doesn't say. Yes. So okay, so we assume that there's no such kind of cases here, and we just need to deal with this. So how should we do that? And as I said, when we are go through the whole array, we can start to have a map and calculate the numbers and the frequency of it. So now we construct this map. This is the first step. Construct the frequency map. And how about next? Next is we are go through this map, and then usually for the top frequent elements, top k frequent elements, we are using min heap to help us. Why? For example, if we have a node, the value is 1 and count 3, so we compare each node based on their count, and then now we are adding another 2. So 2 will be also added here, but remember count is in the second place, and we compare 2 with the 3 to see which is greater. So for the min heap, the smaller one will always be the first elements in the queue. So then if the k is 1, right, it means that this one should be popped out because it never be the top one here, because 3 is always the top one, so we don't need to have this node anymore. We just pop it out. And it means that for a min heap, we always make the size, keep the size equals to the k, and we always have the top k elements there. And after we are putting all the numbers into this queue and having an order, after that, we can pop out all the nodes from this queue to generate our result. So the second step I said, we are put the number with frequency into the min heap. And after that, the third step is we can generate the result based on the min heap. So now more detailed steps here, like how we are construct the frequency map. First, we loop the array, and then we can first to check if the map already have this number. If no, we will map to get or default. So if it doesn't have that value, we can just make it as 0 at first, right? So we will get the number. If it doesn't have, we can just make it as 0 and then +1 and then put it back to the map. This is how we construct the frequency map. This frequency map will initialize at first, frequency map. And then second step, put the numbers into the min heap. Now we have a min heap, so we can start a min heap, and we loop the map, loop the map, and then we put the number with frequency into the min heap. So if the min heap size is greater than the k, it means that we need to pop out the one node to continue to maintain only have top k elements. So we need to put out a node. And the third thing is we need to generate the result based on the map min heap, and that's it. If we are using a list of the integer to store it, we have the result list, and then while the min heap is not empty, we can always pull out the result and add it to it. Min heap, it can pull out the value, and then we also get the numbers there, not the frequency count, into the result. And finally, just return the result. So this is the whole step problem. I will resolve the problem. And what is the time complexity? For time complexity, first thing we just go through the whole array. That will on, and means the number of the elements in the array. And secondly, we put all the numbers with its frequency. Well, definitely if the worst case is each number only have one occurrence, so will also be on. And the last thing is we need to generate the result, so that will be okay, because we only have k elements in the min heap. So the time complexity will be on plus n plus k, so it roughly be like O n plus k. And how about the space? First we use a map, and as I said, the worst case is like each number only occurs one time, so that would be On. And also we have a min heap, and that would be k, so that would be the space complexity. And now let's move to the coding part. First of all, as I said, I will have a map to remember the number to the count map, and use a hash map. And then I go through the numbers because we don't care about the index, so just load the numbers. And now we need to update the map, put the numbers, and also get our default is the numbers or 0 and then +1. And after this, we go to the second step, like we have a min heap priority queue, and then we can use an integer array, only have 2, the size 2, because we can just add the numbers and the count time there. So this is the min heap and equals to new priority queue. And then we can start to loop the map, and let's say how we are like looping the map. So first we will have the map.entry, like it's the integer and integer here, and we'll have the set, and here's the map entry set. And then we are first getting the value set.get key, and also get the count is set.get value, and then we are putting the numbers into it. Number and count. And of course, don't forget that how we are define, like how to compare the nodes in the heap. So that would be like A, B, and then like return integer dot compare like A1 and also B1. We compare the frequency of each nodes there. And now if the min heap size is larger than k, we just pull out a node, and after all this we can generate our the results here. So here, let me check. All right, so now the result could be like int results, and the size could be k because we only return the k top one. And for int like k, and then the results I will be equals to each min heap pull out the elements and got the numbers here. After that, we just return the results. Now let's run it. Cool. So now the test cases are passed. Yeah, and all the test cases pass also as well. So this is how I will solve the problem, especially for a top K problem. Usually when we are working with the top K problem, we are thinking to use a heap to help us to keep the size of the K, which is exactly the top K. If it is a minimum problem, we will probably use a max heap. And also this problem, we are comparing based on the frequency. We also have a map to help us to remember like how many times for each number occurs. So after all this, we start to generate the result. So this is how we solve the top K problem. If this video helps you, please give me a thumbs up. That would be great encouragement for me. And thanks for watching. See you at next video. Bye.